Let's talk about bubble sort. So in the previous video we talked about a search algorithm. In this video and in the next video we're going to talk about a sort or sorting algorithm. Sorting algorithms. So for this video we'll look at bubble sort, but in the next video we're going to look at recursion and merge sort. Why is this called bubble sort? Well, if I go to an animation here, you can sort of picture it, maybe if it was a better diagram, but as it's sorting, you see that the smaller values are going to be sort of floating to the top or bubbling up to the top. And I sort of understand, I sort of get what the person who made this was saying. But for that reason, because it appears like the smaller values are sort of bubbling to the top, that's why they call it bubble sort. Let's actually take a look at what's going on in this algorithm. So the general idea is that we're going to start with the first two elements, we're going to compare them, and if they need to be swapped, we're going to swap them. How do we know if they need to be swapped? Well, in this case, 5 and 1, we want the 1 to be to the left, because this is a sorting algorithm. We want to sort the list from smallest to largest, for example. So we're going to swap this because the 1 is less than 5, so to make it ordered, we want to swap, we want to put the 1 on the left and the 5 on the right. And then we're going to move on to the next two, and we're going to keep comparing these pairs, and then we'll go through again and check the pairs again, and if we go through the entire list and we see that there are no swaps needed at all, then we're done. So what is the algorithm actually doing? Let's skim over the algorithm before we get into it. So we're saying swap equals true at the start. What are we feeding into the algorithm? We're feeding a list. The list is going to be, ideally it's unordered. I mean, if it was ordered, it would just return the list right away. But if it's an unordered list, then it will go through the algorithm. Why would it just return the list if it was already sorted? Well, if it's already sorted, then swap is true. We'd say while swap is true, swap is false. Swap is false, and basically if there are no swaps required, then swap will stay false, and we're not going to re-enter the while loop. We will return the list. That's the general idea. You'll get a better idea when we actually go through it. That's the general idea of why a sorted list will just return the list without having to do the bubble sort. So let's say we have an unsorted list, 5, 1, 4, 2, 8. We'll feed it into our bubble sort. Let's go through it. So we're assigning swap to be equal to true. So swap equals true. For I in range, length of list minus 1. Or sorry, before that, let me back up a bit. So swap equals true. While swap is true, swap is false. What's the point of that? Why would you say swap is true and then say it's false? Because there's a difference between when we're out of the while loop and when we're in the while loop. So when we're in the while loop, if swap is false and we don't actually have to make any swaps, then swap will stay false and we won't re-enter the loop. So the idea is if we don't need to make any swaps, we don't have to go into this loop and we would just return the list. Okay, so that's why we assign swap to be false here. But if there are any swaps required, any at all, then swap will be returned or reassigned to true. So swap is true at first. We go into the while loop. We say it's false, and if there are any swaps needed, this will change to true. So we go into the for loop. We say for I in range length list minus 1. So what is all this? The length of the list, in this case, is 5. But we want to go from 0, from I equals 0, to the length of the list minus 1. So we're going to go from 0 to 3. Because length of list is 5. 5 minus 1 is 4. And for I in range, 4 will give you 0, 1, 2, 3. Right? So if I say for I in range 3, or sorry, for I in range 4, print I, what values will this print? It'll print 0, 1, 2, 3. Right, so that's what it's doing here. The length of the list is 5. 5 minus 1 is 4. So for I in range 4 means we're going from 0 to 3. Okay, so we're going from 0 to 3. Why? Because we don't need to actually go to this index 4 to do the swap. We only need to go to here, to the third index. So that's why. But okay, for this line, we're going from I equals 0 to I equals 3. Let's write down what I is. I equals 0 at first. If list for I equals 0, so if list 0 is greater than list 1, I plus 1 is 1. If list 0 is greater than list 1, then this will be a swap. We'll go through what it actually is doing, but this is going to be your swap. Let's look at this example here. List 0 is 5. List 1 is 1. Is 5 bigger than 1? Yes, so we'll do a swap. Notice if the list was ordered 1, 2, 4, 5, 8, we would never have to do this, because this case where the previous or the left value is bigger than the right value, this is not ever happening, right? 1 is less than 2, 2 is less than 4, 4 is less than 5, 5 is less than 8. But in our case, when we're starting out, 5 is bigger than 1, right? So we do our swap. And how are we swapping? Let's write down what list I is. So list 0 is 5. List I plus 1, list 1 is 1. Okay, so 5 is bigger than 1, so we say temp is list 0, which is 5. Why do we need temp? So temp prevents us from losing this value, right? Because what we're going to do after this is we're going to reassign this to be 1, because we want to move the 1 to the left. So we say list 0 is now the entry to the right, or the 1. So we needed temp in order to save this number 5, because if we didn't do that, we would lose it. Right? If we didn't save a temporary value, we would lose it. So we save it as temp. Then what we do is we then reassign list 1 to be what temp was, which was this value here is 5. And essentially what this is doing is we're just swapping the two values. And this process every time, without going through it, is going to be a swap. So we're going to swap the left and right values. And when we do a swap, we say swap is true. And what this does is it will allow us to eventually go into the while loop again. But we're still in the for loop. So swap is true. But this iteration is done, we're going to go to the next iteration. Okay, so we've swapped the 1 and the 5. Now we've incremented I to 1. And here's our updated list. We swapped the 1 and the 5. So I is 1. List 1 is, because I is 1, we're considering list 1, and we're considering list 2. List 1 in this case is 5, right? List 1 is here. List 2 is 4. Okay, list 2 is 4. List 1 is 5, list 2 is 4. So we will reassign temp. Let me just get rid of that for now. So we're saying, is list 1 bigger than list 2? Is 5 bigger than 4? It is, so we're going to swap 5 and 4. And to go over what we're doing again, we create a temp value. So we say 5 is the temp. We change the 5 to the 4. And we change the 4 to the 5. How did we know to change to 5? Well, we saved the 5 in temp, which allows us to store that value. And what we've essentially done is we've swapped the 4 and the 5. Okay, and swap is true. Now we're still in this for loop, so we increment I to be 2. Swap is true. List 2 and list 3 are what we're considering now. What's list 2? 5. What's list 3? 2. Okay. We won't worry about what temp is right now, but let's go into here. So, is 5 bigger than 2? Yes. So we are doing a swap. So we swap the 5 and the 2. We save temp to be 5. We assign this to 2, and we assign list I plus 1, or list 3, to be 5, based off of temp. Swap is true, and what we've actually done is we've swapped the 5 and the 2. So we go for I in range 3, or for I in range 4, so we go from I equals 0 all the way to 3. So for the last iteration of the for loop, I equals 3. And now we see, is list list I is going to be list 3, list I plus 1 is list 4. So list 3 is 5, and list 4 is 8. Okay, is 5 bigger than 8? No. So we don't go into this anymore. We don't go into this if loop, and we're done our for loop. Now we re-enter the while loop. Why do we re-enter it? Because swap was declared as true, so we re-enter our while loop, because while swap is true, we're going to run our loop. So we reassign swap to false. And we go again through the list. So to maybe go through it a bit quicker this time around, we compare 1 and 4. Okay, there's no swap required. Right, so we don't go into here, and swap is not true because we didn't go in to this if statement. So comparing 1 and 4, we don't need to swap. But comparing 4 and 2, we do need to swap. So we will go into this if statement. Swap will be true. Right. And for this second iteration, I is going to be equal to 1. initially, when there was no swap, I was 0, but at this point, we're in the second iteration, so I is 1. Okay, so we are comparing list 1 and list 2. So 4 and 2, we say 4, so 4 is list 1, 2 is list 2. Temp will be the 4. We're going to store 4 in a temp variable. We'll assign this to be 2, this to be 4, based off the temp variable. So in other words, here we're saying 4 and 2 are swapping. So let's continue without going through this every time again. We're done with the 2 and the 4. We now move to the 4 and the 5. I is going to be equal to 2. But we'll use the diagram. So 4 and the 5, we don't need to swap because 4 is less than 5, so we don't go into here. 5 and 8, so I is incremented again. Compare the 5 and the 8, we don't need to swap. Okay, but swap is still true, so even though we didn't need to swap here at the end, swap was true from an earlier swap. So we go back to the while loop and we enter it because swap was true. We then reassign swap to be false. Okay, and then we go through the for loop again. So again, we're going through this loop from I equals 0 to I equals 3. We're doing the whole thing. So let's compare the first two values. 1 and 2, we don't need to swap. 2 and 4, we don't need to swap. 4 and 5, we don't need to swap. 5 and 8, we don't need to swap. So we don't ever go into this if statement. Swap will stay false. That means we don't re-enter the while loop, and we return our list, which is now sorted. And is bubble sort the best sorting algorithm? Definitely not. And if you go into this website, you'll see that there are definitely better sorting algorithms. So like if I click play, you'll see which one. It looks like this one on the right is sorting the fastest. But yeah, bubble sort is definitely not the fastest. The next sorting algorithm we're going to go over is called merge sort, and this is faster than bubble sort. It's actually a pretty good sorting algorithm. But we'll go over merge sort and recursion in the next video.